So hopefully those demos make it pretty clear about just how much effect you can have on the performance of that copy command. In this next demo, I want to return to a topic from the first module. We talked about choosing compression for your clusters. Now don't confuse this with compression of the source files that you use when loading data. However, the positive impact that this can have on performance is for the same reason. Smaller footprint on disk means less total read from disk, which is going to equate to faster reads. So I'm going to drop that table again and then recreate the line order table. And then we're going to redo the copy. This time, however, what I'm going to do is I'm going to copy in a single file. So instead of copying in all the line order source files that have that same 000 prefix, I'm just going to get the very first one. Now I'm still leaving comp update off. This is the clause that tells the copy command to analyze data as it comes in for potential compression. I'm leaving it off because I want you to see the data before we do anything special. So as you can see, loading only one of those gzip files in, we have, what is that? That looks like 75 million total records have loaded in. Now there's a really handy table called PG table def that will give us information about the total makeup of this table. If I select star from PG table def, where the table name equals that line order table, we get details on each of the individual columns. And if you remember from the previous module, like I said, LZO is the default choice when you leave that table create statement alone and don't do any kind of additional analysis. Now there's another command that we have through the Redshift SQL language called analyze compression, and then you pass it the table name. There's some additional parameters such as the total number of rows that you want sampled, but this gives us a quick glance of how much benefit we could get from compression. If you look at the results of that analysis, there's some that are really quite shocking. For example, your estimated reduction percentage for the line number column is 60%. You have several that are around 20%, another one that is 60%. Ship priority could be reduced by as much as 90% according to this analysis. And it shows the encoding offered. Now notice LZO hasn't been recommended for any of them, so in no column case has the default selection been correct, at least per the analysis that we just ran. So let's drop that table again and then re-import that data from that gzip file. The only change I need to make to that copy command is to switch the comp update clause from off to on. Now last time this run took right around 3.5 minutes, so I won't make you watch that. We'll fast forward into the future. And there we go. With the additional overhead of analyzing the data for compression as it came in, it added right about a minute to our total runtime. But that is going to be an excellent trade-off for the benefit you get in the new compression analysis and the insight that Redshift gets as it's loading data in. So let's select star from PG table def again and see what kind of column encodings we got for compression this time. Now you're going to notice some differences between the recommendations that the analyze compression statement gave us and then what was actually picked during the copy command with that comp update on. There's a variety of influencing factors. One, the number of sample rows that are used to make those decisions, the speed of the data as it comes in, and keep in mind that Redshift doesn't necessarily know how these columns are going to be queried or joined. In reality, using the compression that we have here or using the compression that is given by that analyze compression statement, both are probably going to be better than just going with the default LZO. And don't forget that if you want to go hands-on and get very manual, you can specify exactly the type of compression if you know the data you have and understand those encodings. For me, I like the comp update on style. It's the least amount of work, and I feel very confident that I have a very valid approach to compression for my data. These have been some pretty simple demos. I highly recommend that you get this sample data yourself and go through the larger list of best practices that I gave you the link. I'm going to put it up here again one more time for you. With the knowledge you're building and a little bit of effort with regards to these best practices, you are well on your way to having a very high performance Redshift cluster.